Hey, have you guys heard about the new Parker Sporlan S3C case controller? Contractors, how about a case controller with a one-day setup, access to more data, and efficient system operation for the end user? The S3C series of case controllers provides contractors and store owners automated configuration and network integration. You can maintain precise food temperatures without supervisory control. Easily monitors to prevent product loss, and Bluetooth provides a local connection with the TechCheck mobile app. The series includes case controller display module, a valve supporting open protocol, communication via BACnet and Modbus. Sporlan's mobile app, the TechCheck, allows communication with the S3C case controller to enable proof of work, diagnostic, and data sharing. The S3C communicates with building automation systems and works with Sporlan's SPW series of pulse width modulation valves, also the SSR series of electronic expansion valves. Visit Sporlan.com for more information. Today's podcast is brought to you by United Refrigeration. After more than 70 years, United Refrigeration has become one of the largest distributors in refrigeration, air conditioning, and heating parts equipment in North America. There's over 400 locations in North America, including Canada. Fully stocked stores for immediate pickup, strategically placed distribution warehouses throughout the country for consistent deliveries and inventory replenishment. Brand name HVACR products by top-of-the-line manufacturers, including a complete base of HVACR products offering large and small, common and obscure, anything from ABB to Z-Flex. Let's talk about prompt, comprehensive, and technical services. United's branch employees are in-depth technical knowledge and expertise and valuable resources in providing total customer assistance. Want to get some personal development in? Go to www.uri.com. Go to URI events, and there's an extensive list of every class that's going on at the branches near you. For more information, please go to www.uri.com. Once again, that's www.uri.com. Let's get this thing started. Good evening, everybody. Welcome to Advanced Refrigeration Podcast. You hear the host, Brett Wetzel and Kevin Compass. What's going on this week, man?
Oh, in the middle of a live rack change out. So we've been swapping over systems and all kinds of stuff. So I've been crawling around the ceiling of a 20-year-old grocery store that is just covered in dust. And yeah, so I look like I've been rolling around in a 20-year-old mechanical room all day long. So
how's the actual job doing?
But absolutely horrible. There's just no room to do anything at this place. Like not a lot of engineering thought went into this whole job, how they wanted it done.
Well, because you guys are taking out how many racks and putting in how many?
3 to 2.
So to think you'd have more room.
No. The mechanical room's like 70 feet long. So one rack went out one way, and then, there's pipes coming out of this room all over the place, and they all had to be intersected in like a 20-foot spot. And unfortunately, the mezzanine is too high, so we are like 2.5 feet off the bar joist. So there is like no room to transition pipes and or put hangers up.
Sounds like a whole bunch of fun.
Yeah, it's not been fun, and it's just it's me and your favorite engineering company. So
sweet. So I know but I was stuck in Vegas for 3 days, so that was absolutely just fun. Every single flight had been canceled from Wednesday on to Friday. I finally flew in around 7:00. Dallas got, I think, 2.5 or 3 inches of ice. So yeah, every single flight was canceled. Fun times. This week or tonight, we're actually going to cover testing inputs and outputs, including analog inputs, analog outputs, digital inputs, relays, as well as, we're going to talk about ESR outputs and how to test them as well. So I guess I'll start. We can start with CPC. On the CPC outputs. Unfortunately, it's not a software change when you're telling it if it's a transducer or a temperature sensor or digital. So you do have to set a dip switch on there to basically tell it whether it is whether it requires the 5 volts from the board or if it doesn't. So if you're familiar with CPC on the board, on the multiplex boards, usually it's S1 and S2 that basically dictate whether it's a temperature digital or a transducer. And actually what that's going to do is it actually takes away or adds 4.995 volts DC on those actual inputs. And that's because on transducers, because you are powering up the transducer. And when I refer to a transducer, I'm referring to anything that requires power, whether it be transducer, leak detector sensor, pressure transducer, humidity, anything that requires power is, in my eyes, something that's considered a transducer. When you have a transducer, because you are powering up that item, it's actually inducing voltage back to the board. Where, basically, if you have a typical temperature sensor or digital input, you have that 5 volts there at the board. So if you actually take your meter on there, put it on DC voltage, go from 0 to signal, and switch off the dip switch for the input, it'll actually give you, if you have it on the off position, it'll take away that 5 volts DC of the 4.995. If you turn it on, then it'll actually put that voltage back on there. And we have a test question on one of our entry tests, and the way it reads is, on a compressor proof, what kind of voltage will you get when the compressor is on and being called on for? What kind of voltage would you get at the input board? And a lot of people get it wrong. They'll guess 24 volts, they'll guess 24 volts, and forgetting that digital input there is basically putting out 5 volts DC. And so a lot of people end up getting that question wrong because of just because of the way it's worded. When you have an input that's reading incorrectly, like analog input, a lot of people just replace the sensor there at the case. Usually 90% of technicians, they don't replace it back to where it actually connects to, and a lot of times that will help you kind of figure stuff out, because you might have a break in the wire or a burn on the wire or somewhere inside the case, and just because you're replacing it on that 4 or 5 inch section, it might still read incorrectly. So it's recommended that you replace it all the way back to the connection that's there at the case, where it initially hooks up to the case. If it still reads wrong at that point, the next thing that I would recommend, because you're basically doing 2 things by doing this, but you replace that sensor, you put that sensor at the board and put it in ice water. And what that's going to do is going to do 2 things. One, it's going to see if the wire's good or not going out to the case. It's also going to check to make sure that it's also accurate, at that point as well. If you were to replace it and it wasn't working back at the case, and then you replace it at the board and it's reading correctly with being in the ice water, it's an automatically assumption that that the wire is actually bad there at the board. If you have a multi-wired piece of wire in that jacketing, recommended that you would just replace the whole damn thing, because if one wire got damaged, that's causing a higher resistance, basically bad reading. Chances are it won't be too far off before you start having other issues with the wire and the jacketing. Back to the dip switches, to show you how important they are. Over the week, I got a phone call where I had a gentleman call me up and say that he has a compressor proof, but it seems not to be. It hasn't been broken all the time. It intermittently does. So what I actually had him do is graph the output of the contactor, and also have him graph the input of the digital input for the compressor proof. And that's going to tell you a couple things. One is the digital input saying that the compressor's on when in reality it's not, and vice versa. And one of the things that we did see is, if you graph that and it's working properly, basically both lines should be going up at the same time. They should also be going down at the same time. If they don't, then that's going to show your issue. And basically, what the technician and I both found is, the compressor wasn't even called to be on, and the digital input was actually registering that it was, that the compressor was actually on. We made sure that it wasn't, calling to be on. We made sure that it wasn't intermittently just, closing all of a sudden. We also made sure it had the same amount of wire wraps, because a lot of the current sensing relays that they use have a pretty low amperage that they activate at. Most of them activate at like a half an amp. So I wanted to make sure there wasn't any kind of, voltage going through that basically would make it enough that you would get a half amp. Long story short, the dip switch was actually set incorrectly for a transducer. And, because of this, the voltage was gone. And because of this, it thought that, basically it was open or closed, when in reality it was, the dip switch that was set incorrectly. So it's very imperative that those dip switches are set correctly. Do you freeze, or you got something to say?
No, you just went on for like 10 minutes straight.
Sorry.
No, like Brett was saying about the dip switches, do not use the dip switches as a HOA switch like Novar has, like a hand-on switch. I see more issues caused from guys using the dip switches to force relay points than anything out there. Like, I don't know how many times we come to service calls and we got nuisance alarms, and the only issue is somebody was flipping dip switches. So I mean, don't try to use them as that. I mean, they're there for a reason. They're there for fail safes and other wiring. It's basically to make the relay fail a certain way. But as Brett was saying, so we're going over tests and inputs. So like Brett was saying, how bringing the sensor to the board to see if it's reading right. I do that, and a lot of times what I'll do is I'll take a potentiometer, or I will take a decade box, which is a resistance box that you have set resistance values on, and I'll use that to test my board point. So if I think I got a bad board point, I'll just hook a decade box up to it. Okay, I know it. Say I know at 220,000 ohms, the sensor is supposed to read this many degrees. That's how I'll test it. I'll test the input that way, and it should be reading exactly, pretty much, within point, 1 or 2 of a degree of what it's supposed to be reading at that resistance. So then I'll move the decade box out to the sales floor if I'm having some real weird problem, and I'll check it there, and then see what it's reading. Like Brett said, the 5 volts. I don't know how many times I've seen guys like with you got a bunch of inputs not reading right. Like, say you got a bunch of random inputs not reading right. Guys will condemn a board. First things first, make sure go from ground to the 5 volts, and then the 12 volts. Make sure you have that DC voltage there, because if you don't have that DC voltage there, or it's low, you could have an input dragging down the voltage and affecting every input on there is going to read off. If that's 5 volts and 12 volts powered. So that's one thing to keep in mind, checking that 5 volts and 12 volts, power supply on the plug for the inputs to make sure you actually have it. And, actually going over what kind of device you have. So say it's a 5 volts or 12 volts, if it's board power supplied, obviously you got to flip that dip switch down, because you don't want the 5 volts coming from the input. I mean, it'll work. I mean, a transducer will read, and it'll usually read fine with the dip switch up. A CPC, a 5 volt transducer. Now, when you start getting stuff that's 12 volts powered, or you start putting more power to it, it's not going to read right. So that's when you usually see it. I see dip switches flipped up all the time on transistors, and there's no issue usually. They may drift a little bit, but I mean, just make sure the dip switch is down for a transducer, and then just make sure you actually have 5 volts going out to your red wire. And this would be on a typical like DC signal transducer. So you 0.5 to 4.5. Novar is 1 to 5 volts. It just depends on what you have. A Danfoss is different. I don't know what a Danfoss is off the top of my head, but just make sure you have the right voltage transducer on there. Same thing with temp sensors. Like you could put different temp sensors on there. You could put a Comtrol sensor, a CPC sensor, a Danfoss sensor. You just got to make sure that it's actually set up right and the input is right. When you're doing this, so like for testing a transducer, this is how I do it. I will put my meter first on the ground terminal of the transducer. So on the input, you have SIG and ground. It's marked G and D. So you put your meter lead on G and D, and then you go to the 5 volts terminal on the board where the wire goes and make sure you have 5 volts. And if you do, then I move on to the SIG point. So if it's board 1.1, I go to the ground and the SIG, and I should have, if it's reading zero PSI, I should have 0.5 volts DC on a CPC transducer. And as that pressure increases, there is a chart from Emerson with the 0 to 100, the 0 to 200, the 0 to 500, and the 0 to 2000 transducers on there in the 0 to 650. It'll give you a chart at this specific pressure. It should read this specific voltage. And I'll go through there. It's like, say it's reading 2.2 volts. Okay, say that's supposed to be 50 pounds. If it's not reading 50 pounds, then I know I have an issue, a board issue. If I have that 2.2 volts there and it's actually programmed for that correct transistor, also make sure it's programmed correctly for that particular input. Now, after it's like that, then I know I have a board issue. If I don't have the 2.2 volts there and I'm not reading any pressure, or I'm reading off, or the voltage is off, then I know I have a transistor issue or a pressure issue. So, I mean, that's how I troubleshoot, that. I go to SIG and I go to G&D and I read my voltage and I see what my voltage is and I compare that to the CPC chart. If you hit shift help inside the E2, you hold down shift and help, it will bring up the troubleshooting menu in the E2, and that resistance chart for the ohms and the charts for all the transistors are actually in there.
One of the other things that you can do, because not every single device has, a help sheet where it basically tells you whatever the pressure is and whatever the voltage should be. They make this device on your handheld, on your phone, whether it be for Android or Apple. It's called a linear interpolator. You can put the start, as long as you know the ending voltage, start to end, and also the starting and ending pressure. And that goes for liquid level, goes for leak detector. You could basically use this device and, let's just say you're getting, 500 parts per million. It's 1,000 parts per million leak detector, and the signal is from 0 to 5 volts. Well, technically at 2.5 volts, you should be getting, 500 parts per million. And yes, those are extremely round numbers, but, you can use this for anything that's linear. So any kind of linear temperature sensor, I use it all the time for pressure transducers. If you have the 1 to 6 and 0 to 400, Novar pressure transducer, you can use it for liquid level sensors. It's helped me out a whole bunch of times, just seeing to make sure that I'm getting the right voltage, or seeing if maybe there's a potential offset in there. Also, you have to make sure that you're not exceeding the amount of devices on there that require power.
I was actually just talking to Dave Yoder from Danfoss, and he had informed me, because I had asked the question. I said, how many pressure transducers can you actually have on a Danfoss board before you have too many on there where it starts drawing the power down from the board? Because like he said, if you're drawing down too much power because maybe you have a faulty pressure transducer, it'll change your pressures and temperatures because it's drawing that voltage down. Same thing. You can put too many pressure transducers on a certain board, and it could potentially draw down that voltage off that board, and then cause your numbers to get thrown off. Now on Danfoss, you don't have to worry about that. But if I'm not mistaken, I think on CPC.
Yeah, so we actually just had an issue where this came up the other day at a CO2 startup. The the milliamp draw on the board is actually for what a transistor CPC transistor draws. I mean, I think it was close to like 10 or 12 you could have transistors on there without having any issue.
Really?
Yeah, they actually had like 8, and that wasn't the issue. We had one of them that was flaking out, and it was whenever it got to like 500, 600 pounds, it would short, and it would drag all the 5 volts down.
And it can get so bad where it'll actually draw not only your voltage down on the board itself, but it'll actually, because it's utilizing the same power, it'll actually drop the power on the communication side, and then basically take out a whole bunch of boards with it, or maybe even just that one. One of the things I do if I have a board flaking offline, and I know we're talking about inputs and outputs, but this is just very important to know. If you basically suspect that you potentially have a pressure transducer where you're getting wacky readings while it's running, and then all of a sudden you have a com issue, basically unplug anything that requires power, anything that's a transducer, and plug. A lot of these plugs are modular, so you can plug them back in, a couple at a time. And okay, when I plug this one in, all right, we're still good. And then we plug this one in. Oh, there's our bitch. Then basically all of a sudden that board went in com loss because of that. And I've seen that happen at least 7 or 8 times in my lifetime.
Yeah, generally how I like, if I got a board that's just no 5 volts DC, when I'm troubleshooting with a guy, what I'll end up telling them to do is I'll have them unplug the power supply. So you got that 5 volts and 12 volts power supply. First thing I have them do is unplug that and see if it, and then I'll test it at the board pins. Go to your ground, which is going to be on one of your inputs. Doesn't matter what input. The grounds on the back of the CPC boards are all linked together. Same with the Danfoss boards. So the ground and microthermal. So the ground terminal is linked to all the other ground terminals. If you flip a CPC board over, there is joints leaking every ground, all 16 grounds together. And then on Danfoss, I'm sure it's the same way. It's linked together. I know it is linked together, but because they all go together. Same with microthermal. But you can go to any ground, and I'll check the 5 volts and 12 volts. If I got the 5 volts and 12 volts when I unplug the power supply plug, then I know it's one of my transistors dragging it down. Now, I'm not going to say that's if I have no 5 volts and 12 volts, I will unplug all the inputs. So just pull the plugs out, and I'll see if my 5 volts and 12 volts comes back. If it does, then I know I got an input dragging it down. If my 5 volts and 12 volts does not come back, then I know the board's bad. It's not outputting any DC power on the 5 volts and 12 volts tab. The other thing is, if you have a analog output card on there, also unplug that, because you could also short out an analog output, and it could also cause the 5 volts and 12 volts to drag down.
Have you ever had anything happen with the analog output? Where basically you had something short on the signal wire that actually pulls the COM voltage down that?
Yeah, it will.
I've just never seen it happen,
And I've had the protocols, the Hussman protocols explode, dozens upon dozens of boards because the polarity gets wired wrong on the 24 volts on the IDCM, and it puts 24 volts, or it puts 12 volts difference on the actual analog output and blows it up.
That sounds fun.
Yeah, it's a like problem to the point where like if I start up a new protocol, I rewire the board that the analog output cards on, so it's on the same transformer as the IDCM. So that way somebody can't accidentally reverse the polarity on the IDCM and blow the board up, because the actual IDCM and the analog output card share the same common.
All right, that makes sense.
The common inside of the IDCM shares the common with the transformer. So if it has 24 volts on the common, you flip them around, the IDCM will still work fine. But if you have a center tap transformer feeding that analog output card, you actually put the common of the analog output at 12 volts DC. And when you go 12 volts DC to 24 volts DC, now you got a 12 volts potential difference. So boom, there goes the smoke on the analog output. And I've seen them where it lasts like months or years before it does it. And I've seen them where they burn up like instantly.
Also, like Kevin said, do check the voltage. The reason why that might be important is because if the transformer is tapped incorrectly, in the middle of winter, you might not have a problem. It might be fine. And then all of a sudden in the middle of summer, it'll go off at a certain time, just because when you get a large heat load in an area, your voltage ends up delving down. So if you have it tapped for 240, but it's actually 208 supply power, it might be fine in the wintertime because it might be high enough, past that 208, where it's close enough to that 10% where it doesn't cause an issue. But then you also might have it where, basically in the middle of summer, 2 o'clock, 4 o'clock in the afternoon, the hottest part of the day, when the highest part of the grid's on load, and wham bam, thank you, ma'am. All of a sudden now your voltage going to that board is 18, 16 volts. And I've seen this where, manufacturers have, even put the wrong transformer in. Like they specified it to be a dual voltage, and it was up to the startup technician to basically, make the deciding factor how he was going to tap the transformer. But because he didn't have that option, that didn't happen. So like I said, in the middle of summertime, it ends up going down severely, and then you basically don't have enough voltage to power that board and or throw the numbers off.
Yeah, then I mean that's at every startup. It seems like that is becoming the norm. So I mean, I always double check my transformer tappings because they're always tapped wrong. Especially on rooftop units and like condensers. I see condensers a lot tapped wrong. Usually on the big 460 to or 208 transformers. I mean, they're always tapped wrong. So let's talk 4 to 20 milliamps. This is something that messes guys up a lot. So a 4 to 20 milliamp is a powered input. Usually it's 24 volts feeding the input, 24 volts AC or DC, feeding the input, and it goes across the input, and then it goes to it goes across the device and then goes to the input on the board. Now, in order to measure a 4 to 20 milliamp signal, you need a meter that is capable of doing it, like a Fluke 179, a Fluke 177, Fluke 87, whatever, as long as it measures milliamps. You have to be in line with it. So what you do is you put your meter in line with it and put it on milliamps, and that is how you measure the signal. You have to be in line with the wire going to the board. So you're actually going to be drawing current, a milliamp current signal through your meter. So it is imperative that you wire it correctly, and do not put your meter like mine that has 4 plugs. Like you could put it on milliamp plugs. Do not plug the milliamp plugs in. Your meter leads into the plug and put it to voltage. It'll blow the fuse up and or the meter. I've done it.
I've never.
Yeah, well, I'm sure you've done it. You're just not admitting it.
No, actually, you know what? I never have. No, I'd admit it. Fuck. I've blown lots of stuff up.
So they also make a clamp, but it's like super duper expensive. Fluke does, and it's great if you can get one, but we don't do a whole lot of milliamp stuff. Now, the reason for milliamp transducers, technically, they're a little bit more reliable and robust, and with 4 to 20 milliamps, a lot of stuff with like life safety devices, like leak detectors and stuff like that, a lot of them are 4 to 20 milliamps because at 4 milliamps, if it reads less than 4 milliamps, it's a bad sensor. If you have a 0 to 10 volt sensor or a 0 to 5 volt sensor at 0 volts, you're reading no issue. I mean, if you have, say, a leak detector fails and it's set up for 0 to 5 volts, well, at 0 volts, it's saying you have no leaks. Well, is it 0 volts and no leaks, or is the sensor bad and it's 0 volts? So that's why a lot of stuff you'll see set to 1 to 5 volts or 1 to 10 volts. So that way you get that 1 volt DC. And if it goes under that threshold, then they know the sensor's bad. But 4 to 20 milliamp, like RDM uses 4 to 20 milliamp transducers. There are only 2 wires. That's the other benefit. So now you only have 2 wires. A lot of times they're more accurate, but it trips a lot of techs up because they don't know how to troubleshoot the input. If you see a 2-wire transducer, you have a 4 to 20 milliamp signal more than likely. So you need to make sure you got your 24 volts DC to it, and then you need to wire your meter in between it. So with some alligator clips, or I have like the Fluke little grabby fingers. I'll wrap the wire around there, and then I'll put my meter on milliamps, and I'll measure it and measure the current. And then you can compare that to a chart. So they'll have a 4 to 20 milliamp DC chart with just like we were talking about with the transducers. They have a chart on there where you could actually compare your reading to. So whether it's temperature, pressure, whatever it is, it'll have that reading in there. Same thing with like temp sensors. They have 4 to 20 milliamp temp sensors. A lot of building automation stuff uses 4 to 20 milliamps. Novar low temp sensors, the original like Spectrum low temp sensors are 4 to 20 milliamps. So if you're checking a Novar temp sensor like that, you need to wire your meter in parallel with it. Technically, ohming it out will not give you it's not a temp sensor like a CPC sensor, an NTC sensor. It's not going to give you that ohm reading like it would. You need to check it with it in line.
Yeah, I was always told that the first 3.999 milliamps is basically used to just power the transducer or the temperature transmitter as they refer to it. And that interpolator I was talking about before, same principle. Basically you can use that to like I said, as long as it's linear, which it should be if it's a transducer. Basically you do 4 milliamps for 0, 20 milliamps for whatever the top range is, and instead, like I said, having to do the long division and try to figure out what it's actually reading. Use the linear interpolator. Basically will push out what number it should be as far as milliamps at what pressure.
Today's episode is sponsored by the new Refrigeration differential pressure monitor from Westermeyer Industries. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The new Refrigeration RDP01 differential pressure monitor is available now from Westermeyer Industries. To find out more information, email sales@westermeyerind.com. That's sales@westermeyerind.com.
So have you ever used the handheld to do overrides on any of the CPC stuff?
Yeah, I mean, obviously we've all serviced the Bullseye store with the controller on the opposite end of the world and the rack on the roof. So I mean, obviously that handheld's a go-to thing, especially if you're on the roof and you're trying to check stuff. Plug in the handheld into it. Make sure the handheld's actually set up right for that board. So you need to make sure like that actually input is actually, like if it's pressure, you need to make sure it's set to the right transducer in the handheld or it won't read right. Same thing with temperature. I mean, the handheld's a great tool, especially if you don't have the E2 right there. Same thing with overriding relays. You could override relays from the handheld, which is great to test them, which is generally how I will test relays. If I'm doing anything with it, I'll unplug the comm line and I will take the handheld and I will use the handheld to override the outputs. I don't flip the dip switches because that's not really a good test. And then it ends up messing stuff up half the time. And I swear, like half these boards fail because guys are messing around with the dip switches. So what I generally do when I test outputs is I plug the handheld into it, and I use the handheld to force the relay on and off.
Yeah, I believe you can do that with analog inputs as well as analog outputs. And I think the ESR boards as well, you can actually utilize that as well to do the overrides on that.
I've never actually tried it on an ESR board.
I've never done either. I was reading, one board lonely night, and we're going through the CPC manual, but apparently I never read how to do the logging on UltraSite.
Yeah. Yeah. I mean, so if you're testing stuff, I generally jump to the handheld. I mean, I carry one in my van. I mean, they're expensive and kind of hard to find, and hopefully they come up with something better and like a display actually on a board here when they update the board in the next like 20 years.
Yeah. By the way, on page 26 of the CPC manual, it is showing that you can set an override value on here for the analog outputs.
Yeah. So I mean, using the handheld's great for testing outputs. Now outputs with CPC, like obviously you would change what the output does when it's called for by flipping the dip switch, whether the light is on when it's called for or is off, whether it's in fail-safe when it's in comm or not. Now, when things need to fail on, like compressors, condenser fans, circuits, you want to wire them normally closed. When you want to load to fail off, defrost, stuff like that, usually defrost and stuff like heat reclaim, stuff that you don't need, you don't want to run. You want to wire those normally open. Okay, so if the board loses power, if the board completely takes a crap, it's going to fail in that state. Whether the dip switch is up, down, it's going to fail in that state if the board is toast. So if it's in comm loss, you are going to fail on the dip switches. So, and your wiring. So if it's normally closed, if the relay is wired normally closed and the dip switch is up, which is how all refrigeration should be. So when it's called to be on, it's going to be on. Now, if it goes into comm fail, it's also going to be on. If the board takes a crap, it's going to be on because it's normally closed. The relay is. The Form C contact is normally closed. It's going to be on. Now, if it's normally closed, dip switch down, when it calls for it to be on, it's going to be off. Same thing if it was wired normally open, dip switch down, when it calls for it to be on, it's going to be on. If the dip switch was up and it was wired normally open, it's going to be, when it calls for it to be on, it's going to be off. It's going to reverse the action of whatever it calls for. So the light being on is reversed by the dip switch. And go ahead, Brett.
The light being on is just letting you know that the load is programmed to be on. Is
Correct.
Basically all it's really doing. It doesn't necessarily mean that it's actually on. It just means that the load is basically energized. And unfortunately, there's no, I guess you could if you took the board apart, but there's no way to really prove if because all those relays on the multiflex board are 12-volt DC relays. So, I mean, there's no way to really tell if the relay itself is getting power because like I just stated, just because the red light is on doesn't mean the coil's actually activated, on that board itself.
Correct. I mean, it just depends where your dip switch is. And if you have Novar, Just so you guys know, when the light is on, the load is off. On the older Spectrum boards, when the light is off, the load is on. Meaning the normally closed is closed, the normally open is open when the light is off.
That threw me off for so long.
Yeah, I mean it's backwards on Novar, so like guys just pay attention to that. So I mean it confuses people. So, and then Danfoss, when the light is on, when it's, I don't do a whole lot of Danfoss. When it's red, it's on, correct? Or is no, it's green. When it's red, it's overridden with the switch. Yeah,
Yes.
it's green. It's green when it's calling to be on. It's red when it's overridden from the switch.
Yes.
And then microthermal is the light is on when it's on, and then you could wire it. Your fail safe on microthermal is wired either way. So you have normally open, normally closed. Now it's a Form C contact, so you have a normally open, normally closed. Now remember, everybody but Novar has fuses. So CPC boards, they all have fuses.
Hold on. 2 amp fuses, because we need to specify, because you can't just, throw whatever in whatever. Like CPC is rated for 2 amp. Danfoss is rated for 5 amp. Wait a minute. Microthermal, they have fuses on the relay outputs.
Yeah.
Oh, no, you said Novar. I'm sorry.
Yeah, no, the newer Novar boards do, like the newer BACnet and the newer Spectrum replacement boards do. But the older Novar boards, the older Spectrum boards, and the version of the Logic 1 boards, none of those have fuses on the outputs. So when there's a short, the board point blows up.
Cool.
But usually at Walmart, when there's a short, the time delay eats it first, because that's get the weakest contact rating of everything in the system. That's why you find so many bad time delays at Walmart.
So what's the amperage on the fuse for microthermal? Those 2 amps as well?
Yeah, they're literally the same fuse as CPC.
Oh,
it's like the same exact fuse.
They're tinier though.
No, they're the same fuse.
No.
It depends what board you have.
It's not, because I'm looking at, okay, maybe you're right about which one it is, but this right here is a microthermal fuse.
That's a 500 board.
Okay.
Yeah, that's I hardly have any of those. All my stuff's 700 boards.
Just saying, it's not always the same one.
So I mean, they're all fuck off. Great. Now we gotta edit that out. So yeah, just check the fuse. So if you have power coming into your common and you have nothing going to normally open and normally close, and the board point's calling for it to be on, say it's calling to be on, it's wired normally closed, and CPC, it's wired normally closed, dip switch up, and you have nothing, you have voltage between common and normally closed. You have voltage there. The switch is open. So when you have the switch is open, you have voltage, you have potential across it. So, and you shouldn't. So first thing I'm going to do is unplug that relay output. I'm going to unplug it. I'm going to throw a meter on ohms. I'm going to go common and normally closed. If I have no continuity there, if it's not showing the switch is closed, the relay is closed, then I'm going to, pop the cover off or the fuse out. It depends which one you have. If you have the turnstile fuse or if you have the one with the cover, and I'm going to see if the fuse is blown, and I'm going to, check across the fuse. Fuse is blown. Obviously, figure out why the fuse blew, change it out, and you're good to go. Danfoss, you could pull the cover off. The black cover, same thing. You can see if the fuses are blown. Microthermal, same thing. The 700 boards on microthermal are kind of a pain in the butt to get the cover off. It'll come off, but be very, very careful, because underneath the cover is a ribbon cable that's going to the front of the board. And if you pull too hard, you get overzealous. You got to pinch the sides of the board to get it to come off. And if you get overzealous, you'll pull the ribbon cable off and spend the next half hour trying to get it back on. Don't ask me how I know. I've done it multiple times. And then same thing, you got fuses underneath there. So just make sure you check your fuses, make sure they're good. Now on microthermal, on the 700 boards and the 500 boards, they have a relay override button. So you push the button, it closes the relay. Now, if this is a relay that's wired normally closed and calling to be on, and you push the button, it's going to do nothing. It only closes the relay. It will not open the relay. Same with the 700 boards. If you push the button and it's already calling to be on, it's not going to do anything. And with the 700 boards, you could actually switch the action of the relay. You could tell it that it's normally closed, normally open, fail safe. You could switch the action in there, depending on what it is.
Also, drop the power. Like I don't know how the microthermal is. I would still recommend doing it, but drop the damn power before you pull that cover off, especially with the Danfoss boards, because like the override switches that are on the relay out part of the board, they're small little I don't know what you would call them, basically
Micro switches, basically. Like
yeah. But on the other side, what would you call that? They're basically pieces of brass or copper or whatever that basically plug into the board, and if you cross that out, you could basically blow up that board. So even Danfoss, when you're talking to them, they're going to recommend that you drop the power going to the rest of the boards to make sure that doesn't happen. Also, if you are up a certain creek without a paddle and you need to, let's just say you got something wrong with your Danfoss where it's not throwing anything in defrost because we're having comm issues and we got to basically throw the cases in defrost. And not every single relay output board on Danfoss has the automatic switches where you can actually set it. So actually what I have in my truck or did before I got the stalker mount vehicle, basically I had the Danfoss, one of the Danfoss tops that actually had the switches on there. So if God forbid I needed to activate a set of contacts or whatever while I'm sitting there doing let's just say putting a racket defrost or whatever, I could basically turn off the power, pull the cover off that doesn't have the switches on there, put it in one that does have the switches, and basically just switch it like for like.
That's too much work for me.
You're such a jerk.
Yeah. So guys, that's a basic overview of how to troubleshoot inputs and outputs. I want to eventually go into showing you guys like a small video. We're going to put up a couple of YouTube videos of how to check it with a meter, like checking the DC voltage on the boards, and then 40-20 milliamp. Brett has a power supply that we could use to show you guys how to check a 4-20 milliamp transducer. I actually don't have a 4-20 milliamp. Go ahead.
Finally found it. All right, so before we go, because I guess we're going to go over ESR testing later.
Yeah.
Okay. So technical bulletin number 026-4211. This is on CPC. The new IO board feature relay output test mode. There's a procedure in here where you can actually set, I think you set I haven't read through it all the way, but I've been looking for this, since we've been reading, but, they have, you can basically test each individual relay output by, messing with the switches, so basically you can set the dip switches to a certain way, and it's going to make that relay activate on or off based off that. And I thought it was that you set all the addresses and the baud rate to 0. Like I said, I haven't read through it fully because I literally just found this thing, but I just want to make you guys aware that you can do that. Once again, that's bulletin number 026-4211 CPC technical bulletin. At the top, it'll say new IO board feature relay output test mode.
Yeah, I've never tried that before. I mean, it seems great, but it also seems like a super bad idea for somebody to be flipping all those dip switches.
Such a negative Nancy.
I will say this, just so you guys know, because this happens all the time. If you flip a comm dip switch, like say you flip number 3 on S2, or I'm sorry, S3, and it was down and you flipped it up because you thought it was going to override do the overrides, and you leave that, it will not change the COM of that board until that board is power cycled. So what happens is guys will flip a dip switch and realize they didn't flip one of the relay dip switches, they flipped the COM dip switch, and they forget about it. And this happens all the time. I see boards get condemned all the time because they're after a power outage, they won't come back online, and somebody thinks they're bad because they won't communicate. Well,
did you find that one day out on a rough?
I found it out. I find it all the time on the roughs. Honestly, I find it all the time, because nobody notices until a power outage goes.
Yeah.
So we used to have this chain up here called Dominic's. Like they got bought out by Safeway. Well, every Monday morning they did a generator test at 9 a.m. At like 10 a.m. every Monday morning. There was like 100 of these stores. At least one or two came in with a COM loss.
Wow. So did they have on-site techs or what?
They had some on-site techs. They had multiple contractors. So everybody shared these stores. So every Monday morning calls would come in for COM loss, and it was because it went into a generator test. And for that split second, when that generator flipped over, you had that board powered down for a split second, powered back up. Now it's got a new address.
Wow.
So that's why I'm one for guys not messing with dip switches, because it always seems like it ends up ending bad. But yep, use that handheld if you're trying to force stuff. Just make sure you check in with the meter, and again, just make sure you got that power supply there, that 5 volts, that 12 volts. Oh, also, last thing, if you have a board that is just an input board or just an output board, it has to be a center tap transformer with CPC. If it's a multiplex board, meaning it does two things, it has to be, or it can be, a 24 volt power supply, AC or DC.
Is that because I'm assuming that's probably because of the using the 12 volts,
Correct.
That's ended up being rectified for the relay outs, right?
Correct. That's 100% the reason.
Oh, okay.
Yeah, that is 100% the reason. It's using the 12 volts for that. Now you could center tap a multiplex board. That's just, you don't need to. And then same thing with the ESR board. They call it a multiplex ESR board, but it needs to be center tapped. 100% will not work unless it's center tapped, because it's using the 12 volts to power the valves.
Absolutely.
So